If you spend any time developing Go code, you're going to inevitably end up spending some time looking for bugs or debugging your code. There's a lot of different strategies that you can use to do this. So one of which is just thinking hard at your code, especially if you've written your code. Sometimes this is all you need to find the flaw in your logic. Other times you can add print statements to your code, and this will help you narrow down where the bug is faster. And lastly, you can take it a step up and use an interactive debugger to help you figure out where the bugs are in your code. And that's going to be the focus of this talk today. My name is Suzy Mueller, as I was introduced, and yeah, I work on the Go Tools team, and I'm going to be taking you through the Go editor debugging experience today. So a quick intro to interactive debuggers. If you haven't used one before, it allows you to set breakpoints in your code where the program will stop on that breakpoint and allow you to look at the state of your program, as well as step through and investigate different things like the call stack and what variables are in scope. And we're going to be looking at all of that today. So we're going to be doing this in a hands-on demo, which you're welcome to follow along with. But instead of doing a kind of generic demo of where we try to find a bug that I have accidentally left in the code somewhere, I decided to spice it up, and we're going to do something hopefully a little more fun, which is we are going to go on a treasure hunt using the debugger to find our clues and get to the treasure at the end. So to set up for this, I'm going to be doing this treasure hunt using VS Code. So you need to install VS Code and the Go extension, which can be found in the VS Code marketplace. We also need to install Delve, which is the Go debugger. So this is the back end of the debugging experience, which will allow you to set breakpoints and look at the values of variables in all of the things that we are going to be seeing today. And lastly, you need to download the code of the treasure hunt. So you can download it from GitHub, and then you want to open the root folder in VS Code. Quick note here, do not read the source code if you do not want to ruin the surprises of the treasure hunt. So let's get a quick lay of the land of what we're going to do today. We're on GopherCon Island looking for the treasure, and we have a bunch of different locations on this island that we're going to visit and look for clues using the debugger along the way. This is implemented as a web server that just serves some static HTML pages, and then also creates Go routines where we will stop the program and look for clues in the code using the debugger. All of the locations that we saw on the previous map are in their own package, and we'll be using the URLs to navigate between these locations. So let's quickly lay out some ground rules. First, always run the treasure hunt in the debugger. We're doing this treasure hunt to get familiar with the debugger, hopefully learn some new things, and if you don't run the treasure hunt in the debugger, the treasure hunt will actually crash because we use a hard-coded breakpoint from the runtime package that allows us to stop the program in different places, and this feature will not work if you're not using the debugger. Second, as I mentioned before, no browsing the source code. I did my best to hide the clues, but if you just read through all the files, you would be able to find the clues and know what to do. On a similar note, don't use any language features. We aren't going to be using those. For example, if you want to see the value of a variable, we won't use go to definition, but we'll use the debugger instead to find that value. And last rule is to have fun. This is a game, so let's not take it too seriously and try to learn something along the way. So with that, I'm going to go over to VS Code and start the treasure hunt. So here I have my VS Code window open, and I have the Go Nightly extension installed. So this is a preview version of the Go extension, so I'm getting any of the latest features to try out. And I have the GopherCon module downloaded. Here in main.go, we have the web server, And then we have all of these different packages that are the different locations on our treasure hunt. So now we need to launch our program. So I'm going to open this debug view. I can see that I can select Run and Debug here, and this will launch our program and allow us to debug it. But instead, I'm going to take this opportunity to talk a little bit about launch configurations. So I'm going to create a launch.json file where we can define different configurations that we can use to launch our program. And a launch configuration is just a piece of information that we can pass to the debugger to tell it about what settings we want in our debug session, as well as what program we actually want to launch and debug. So I'm going to select Create a launch.json file, and I'm getting a few options, and we can edit all of these in our launch.json file. So I'm just going to go ahead and select this first option, and we'll talk about the different settings more once we get to the file. So now that we've added this configuration to our launch.json file, it's pretty simple. All we have is an array of configurations, including this one we just added. So let's go through all the fields and talk quickly about what they mean. So first, it's just the name. So this allows us to identify which configuration we've chosen. It appears up here on the left so that we can choose which ones to actually launch. The type is Go for obvious reasons. And then the next part is request. So the type of request we're doing for this debug session is a launch request. And what this means is that we are asking the debugger to actually launch our program, and then we will connect to it and do everything that we want to do. And then at the end of our session, the debugger will kill the program, and it will be done. We've launched it entirely within the debugger. If we instead change this to attach, we would then be attaching to a process that's already running. So the debugger would not be responsible for actually starting the process. So the next field is the mode. And so this mode of auto is specific to the VS Code Go extension. And it allows you to use the same launch configuration for both testing and regular packages. So if I have a test file open, then it will automatically change this mode to test so that I can debug my tests. But if I have, for example, main.go open, then this mode will instead become debug, and we can just debug the package as normal. So the last field is the program. And so this is what we are telling the debugger to launch. So in this case, it's going to be the directory of the file that we have open. And for our purposes, what we want this to be is that root directory that we have open, which contains our main package. All right, so we've talked about this whole launch configuration. So I think we're ready to actually start our treasure hunt. I'm going to navigate back to main.go, and we're going to hit launch package. So as we do this, we see that a toolbar appears on the top right that has some options to pause or stop our debug session. And another thing that may appear, but in my case didn't yet, is the debug console. So the debug console, there's one of them associated with each of your debug sessions. And it includes some logging from the debugger, which are these first few yellow lines, and then also output from our program. So here we have a message from our web server that said listening on port 1234. All right, so and we'll talk about everything else that's happening here on the left in this debug view as we go along. So our server is listening on port 1234. So let's go ahead and connect to it. So we have our first instruction, which is our gopher got a text from Eve that says, I overheard something about treasure on GopherCon Island. Meet me at the bar, and I will tell you what I know. So this is our first clue. So we're going to navigate to the bar by specifying bar in the URL. So let me go ahead and type that in. And we've reached the bar. There's a bunch of different gophers here, and we need to speak to Eve. And we're going to do this by finding the stack frame that has Eve on it. But the first thing we need to do is find our go routine that contains our clue. So we're going to start this. So we've hit this hard-coded breakpoint. I'm going to get rid of this debug console view so we can have some more space to look at the code. And so we've hit this hard-coded breakpoint, which is here, the runtime.breakpoint. And we can expand the call stack. And what we see when we've expanded the call stack is we have 4 different go routines here. So each of these is, Go makes it really easy to write highly concurrent programs. So we're often going to be dealing with programs that have multiple go routines running. And we can investigate the call stacks of each of them. So let's take a minute and look at what information is presented in each of these labels before moving on and looking at the stack frames. So here we have that same line from our call stack view. And the first piece of information that we get is the go routine ID of the specific go routine that this line represents. Next, we get the function name for this go routine. So this is the function where the go routine is stopped on. So we see that the package name is at the beginning. We have GopherCon/bar, and then the function name follows it. So gather intel. Next, we get the thread ID of the OS thread that this go routine is running on. So not all of the go routines are going to have this piece of information because not every go routine is scheduled to run on an OS thread. So if it's currently running, we will get this piece of information here. Lastly, we get more information about the state of this go routine. If the go routine is running, it will say running. But if it's stopped, we may get some additional reasons about why it is stopped. So for instance, this go routine hit a breakpoint. So we have some additional information that this was paused on breakpoint. If you didn't notice, all of the go routines were paused in our call stack view. So let me navigate back and we can look at that. And we can see that they're all paused. And this is because the go runtime does not allow us to have certain go routines running and other ones stopped. So when the go routine 53 hit the breakpoint, all of the go routines stopped and we were now able to investigate the state of our program. So we're going to, for the rest of the time, also have all of our go routines are paused or all of our go routines are running. So now that we know where to look for our the bar where our clue is, we can expand this stack trace. And we can see that we have a bunch of stack frames here. This first one matches the function that we're stopped on. So it contains the name of the function as well as the location in the source code. If we then select a different stack frame, for example, Alice, the location in the source code that we're looking at gets updated to match, and the context that everything is evaluated in also gets updated. So what does this mean? So our original stack frame didn't have any local variables. And if I expand the variables view, we can see that. But if I then step up and step into Alice, we instead see the local variables that Alice has, which is what she's saying to us, which is, sorry, I don't know what you're talking about. But if we go ask Eve for our next clue, Eve will tell us that I left the first clue in locker 7654321 in the gym. So that's our next clue. We need to go to the gym and go find locker 7,654,321. So to do this, first I'm going to go back to VS Code and I'm going to hit continue. I need to do this because, like I was saying before, either all of our go routines are running or they're all stopped. So if they're all stopped, it's not going to be able to serve our next request to go to the gym. So we need to make sure to hit continue first. So let's leave the bar and go to the gym. So we've made it to the gym. We have a bunch of lockers to search, and we're going to use the variables view to do this. So we've again hit a hard-coded breakpoint, and we can see that we have a local variable named lockers. I'm going to collapse the call stack view so we can have a little more space. And so there's a lot of lockers. There's over 12 million lockers, and we need to find the one locker that contains our clue. If we expand this slice of strings, we see that the contents, we didn't just get a list of all 12 million lockers. Instead, these are going to be paged. And this is for performance reasons. Instead of trying to load all of the lockers or just some of them, these are paged so that we will only load the ones that we are actually looking at. So if we dig in, they'll continue to be paged until we get to the last 100, and then we can see each individual locker. And all of these lockers have dirty socks in them, so they are not the locker we're looking for. So let's go look for locker 7,654,321. So even with this being paged, so it is more performant, but I still have to do this search, and I'm kind of lazy. I don't really want to do this. So we're going to use another feature of the debug console to actually be able to do this really quickly and easily. So the debug console, as I mentioned before, includes logging from the debugger, as well as output from your program. But it also provides a way for you to evaluate different expressions. So you can specify different expressions that will get sent to Delve, and Delve will evaluate these expressions and give you back the results. And we can use this to find our one locker that we're looking for. So let's go back to VS Code, and I'm going to open up the debug console. I'll again collapse this on the side so we have a little more space. So down here at the bottom, we can specify some expressions. So if I type in lockers, I'm going to see a very similar thing to what we saw in the variables view, where if I expand it, I'm getting these paged lockers. So this didn't really solve my problem, but we can actually just request a single locker. So if I instead try to access the specific locker that we're looking for and hit enter, Delve is going to evaluate that for us and give us the answer we're looking for. So this is our next clue. It says, this locker contains a note, meet the monkey in the jungle. So that is our third clue, so we need to go to the jungle. So let's go back, hit continue, and switch over to our browser again and go to the jungle. So we've reached the jungle, and now we have to figure out how to speak to the monkey. So the monkey that we have is a process with the name monkey, and we're going to need to attach to this process and then figure out how to trap the monkey and get our next clue. So we're going to do this by creating a second debug session in addition to the one we already have running that will attach to the monkey and allow us to investigate that process as well. So we're going to go back to our launch.json, and we are going to add another configuration to do this. So I'm going back to the VS Code. I'm going to open launch.json and get rid of this debug console. And let's add a second configuration. So I'm going to hit Add Configuration, and I'm going to choose this Go configuration that allows you to attach to a local process. So we now have a second configuration here, which is also of type Go, but instead of launch, our request is now attach. So the code executed a binary called monkey, and we need to attach to that binary to debug it. So we're going to do this by specifying the process ID of the process we want to connect to. So you can do this by using your machine to find the process ID, however you would normally do that. But we can also use a feature of the VS Code extension that will provide a process picker and allow us to choose the process that we want to connect to without having to know the process ID off the top of our heads. And we can use this by specifying the name of the process that we want to connect to. And if the extension finds only a single process that matches that name, then it will automatically connect to it for us. So I'm going to replace this 0 with monkey, which, hold up. Yeah, and we're going to hit save, and then we're going to launch using this configuration instead. And the extension will find the process name monkey, fill in the process ID to be the correct number, and will then send that information to Delve. So let's go back to our debug view. Let's toggle over to the attached to process configuration, and let's hit debug. So not a lot has changed, but we actually have successfully started a second debug session. So we can see here on the toolbar, we now have the name of the current debug session that we are looking at, which we can switch to attach to process. And if we look here, we can see that this stop button has switched to a disconnect icon. And this is because by default, when we're attaching to a process, since the debug session wasn't the one that launched it, it's not responsible for cleaning that up. So instead of killing that running process, we're just going to disconnect from it and allow it to continue. So now that we've done that, let's stop on the attached to process one. So we see that we still have two separate debug sessions. The launch package one is still running, but we have our attached to process one, which is now paused. And we're also going to have two separate debug consoles for each of these. So let's take a look at what's happening and see how we can get our clue from the monkey. So we can see that we're in this loop on line 14, where we have some bait in a trap, and we really want to catch the monkey, but the thing that we've put in the trap is not what the monkey actually wants. So let's go to the variables pane and see what we have in the trap. So we are trying to bait the monkey with a banana, but the monkey doesn't want a banana. But we also can't see in this variables view what the monkey wants. And that's because I_want is not a local variable to this scope. And by default, for performance reasons, the debugger does not load the global variables, but instead will only do that if you change the configuration to do so. So our options now would be to go back to our launch.json, add show global variables true to our launch request, or our attach request, and then start our session again. But if we were in a long debug session, this might be annoying to have to restart the whole thing to change something that we didn't know we needed when we started. So instead, we're going to use another feature that we provide in the debug console to make this configuration on the fly. So in the debug console, Delve has provided a few additional commands that allow us to change things like the configuration on the fly. So by specifying these expressions, which wouldn't be valid Go expressions anyway, we can make changes to the configuration. So let's go back and open up our debug console so we can figure out how to trap the monkey. So we now have the debug console open, and this is a separate one from the launch package debug configuration. And we can specify the command that we want to run. So let's first quickly look at the help for the configuration. And we can see that to change the value of our configuration, we specify delve config with the parameter in the value. So to update show global variables, we're going to type delve config show global variables true. So now when we go back to the variables view, we see that we have two different scopes. We have the locals and we have the globals. When we expand the globals, we now see the value of I_want. And if right now you're thinking, we could have instead in the debug console typed in I_want, surely Delve could evaluate that expression. We absolutely could have, and we could get that value here. as well. So that would be another way to do it. But if you want to see all of the globals at once, we can also use the debug console to update the configuration. So now that we have the value that we want, how are we actually going to use this? We're going to do this by using a feature called setVariable. So I'm going to right-click on the value of I want. I'm going to copy the value. And then I'm going to set the value of bait. So we're going to change the value of bait to ice cream. So this is another feature provided by the debugger that is useful in scenarios that are very similar to this in the real world. So if you have a loop that has, is running many iterations, and it's not important for what you're actually trying to debug, so you just kind of want to skip ahead and get past it and not have to wait for the millions of iterations that it's going to do. You could use this feature to skip ahead so you can break out of the loop early and continue on with finding your bug. So now that we've done this, we're going to catch our monkey in the trap. Okay, we successfully broke out of that loop, and we were able to catch our monkey in the trap, and the monkey panicked. Let's take a minute to look at all of this information that we see here, and I'm going to do this on a slide so we can focus in on the different parts of what's happening on this screen. So here I have the same screenshot as we had before. We can see that the stopped reason here is panic. So this is the same thing as we had where it was paused on breakpoint. Instead, we are paused on a panic. And what the debugger does is if there is a fatal panic or a fatal throw, it allows you to, it catches the program before it exits and gives the user a chance to investigate the state of the program right before it's on its way down, it's shutting down. So it does this by setting internal breakpoints. So for example, this one, there's an internal breakpoint set on fatal panic that allows us to see the state of the program here and catch it before it exits. We get some additional information from this exception info, which includes the call stack, which is also something you would see on a panic when it crashed. And what's important for us today is this message that was passed into the call to panic, which is our clue, which says the butterflies in the garden can tell you where to find the treasure. So there we have it. We're on clue number 4. We need to go to the garden. Let's navigate back and go to the garden from our browser. So I'm going to hit continue and allow this monkey process to exit. So now we just have that single launch package session again. And we can now go to the garden. So we arrive at the garden, and there's a bunch of butterflies flying around, and they're trying to tell us something. So we're going to look at a certain variable and try to figure out what they're trying to say. So we have 10 different butterflies that are flying around this garden. And we have this function here called watch butterflies. So let's set a breakpoint there and try to figure out what's going on. So let's hit continue. And we can see the value of pattern here on the right. So I'm going to zoom out real quick so that we can see the full contents of that string. And let's hit continue a few times. Another way for me to actually kind of pin an expression or a variable is to right-click on pattern, and I can add it to watch. In this way, it appears here in this watch view, which gets updated every time the program stops. So if I have a lot of variables and I need to dig through, or it's something that's really far nested, so you often are going to have to dig into a mapped or a struct to find the value, you can add that to the watch view, and then that will get updated every time the program stops without having to do those extra steps. So let's continue. Clearly something's happening because it's changing, but I don't really see a pattern here. And we're going to use another feature called log points to try to get a bigger view on what's happening. So what is a log point? A log point is a special kind of breakpoint that where the backend does not break, but instead prints a log message. So this means that instead of the program breaking and allowing us to investigate, the debugger will, when it hits this log point, will print out a user-specified message to the debug console, which we can then later go back and investigate. And we can also provide different expressions to evaluate to that log message. These log points are very similar to print statement debugging. Essentially, it's just about the same workflow. You can specify log points at different places, and if you run it through the debugger, it will act very similar to print statement debugging. An advantage over print statement debugging is that these messages never actually get compiled into your code. So you don't have to worry about accidentally leaving them behind to get caught in code review later, which I have definitely done, or even having them commented it out. But a disadvantage of doing this through the debugger would be that it's not as performant as if you would just add a func.printf to your code. So let's go back to VS Code and use the log points to try to get a bigger picture of what's going on. So we're going to do this by right-clicking on the breakpoint and selecting Edit Breakpoint. We're going to navigate to Log Message, and now we're going to specify the value of the message that we want printed out. So we could just type in hello or whatever we want to say, but what we really want to look at is pattern. So we just want to add pattern as an expression between the braces so that we can, it'll just print out the value of pattern. So we hit enter, and now this breakpoint has been updated to be a log point, and we hit continue. So the program's no longer breaking, it's just running, which is exactly what we wanted. So let's navigate back to the debug console so that we can see what's actually being printed out. So we can see that it's working. We're getting a lot of different messages printed out. Each of these starts with the Go routine ID, very similar to how we see that in the call stack view, followed by the message. So this is pattern that's being printed out. And then we also have a link back to the location in the source where the breakpoint is so that we can see where this log message is coming from and what context everything was evaluated in. So if I click on this, we get sent back to where our log point is. Now that we have this, we're getting a bigger picture, but it's still not very clear. And this is because we are looking at a bunch of different Go routines or a bunch of different butterflies, which are flying in different patterns, and we need to focus on a single butterfly in order to get our next clue. So let's do this by, again, editing our breakpoint and adding a condition. So let's do edit log point and switch to expression. So by adding an expression, we are making this breakpoint a conditional breakpoint, which means that we are, the breakpoint will only break when the expression is true. So if we want to, in this case, we want to do this only when a certain butterfly is running this function. We don't want to print it out every time any butterfly is running this function. So we can see from this comment that the IDs are between 0 and 10. So these do not line up with the Go routine IDs that they have. These IDs are a separate value. So let's just check for the first butterfly with ID 0 and hit enter, and it's updated our log points. So we don't see anything different, but that's because I haven't scrolled all the way to the bottom where this update has actually taken place. And we're getting a clear picture. Let's zoom out so we can see what it is. So we have a palm tree. So this is our next clue. This is what our butterflies have to tell us. We're ready to move on and go find our treasure. So our clue is a palm tree. And if we go back to the map we had earlier, we can see that the palm tree, the only palm tree on the island, is on the beach. So we need to go to the beach to hopefully dig up our treasure. So let's do that by specifying beach in the URL. So I'm going to go back to VS Code. I'll zoom back in. And I'm also going to disable this breakpoint. And this is because we're printing out a lot of messages. Let's not add any more clutter or slow down our debug session. So we're just going to get rid of that log point. All right, so let's go to the beach. So we've made it to the beach. We have a bunch of different locations. So in this case, these are actually going to be the names of the functions that we're going to. And we need to go find the palm tree. So we're here on the beach, and we can't actually see where we're going. The functions aren't immediately visible in the source code. So we're going to have to use the toolbar to navigate through the code. So far, we've only really used the play or the continue and the pause button. But for this section, we're going to focus on using the stepping function. So this is something that if you're debugging code, you're probably going to want to use, where you'll set a breakpoint and stop somewhere, and then you might want to step through and see how things change. So there's 3 different options for stepping. The first is stepping over. So this allows you to just step to the next line. So if you have a function call, you won't step into the function call. Step in allows you to step into that function call, so you won't step to the next line, but will step to the next line, including any function calls. Step out allows you to go back up a level. So if you are in a function, for this example, fPrintLine, if you select step out, it will take you back to where that was called. So let's start stepping. I don't know where the beach is, so let's just start stepping in so that we can figure out where to go. So I'm kind of just clicking through quickly. And this is a bit of a journey. I don't know when it's going to end. So I kind of want to do this quicker. I don't want to just keep hitting this. I don't know where it is in our source code, so I can't set a breakpoint that way. But I can set a breakpoint using the information that I have, which is the function name. So from the breakpoints view, I'm going to select add a function breakpoint. And then I can specify the location that I want to set a breakpoint on by just specifying the name. So I'm going to type in palm tree. And so now I have a breakpoint set on the function palm tree. I hit continue, and we go straight there. No more stepping. We're able to set a breakpoint just using the function name. And we've reached the end of our journey. It tells us a link to go to where we're going to find our treasure. And if we go to that link, we are rewarded with a golden gopher for completing our treasure hunt. So this treasure hunt used a lot of different features that are available for debugging. We went through all of the different views that we had available and used those to find our clues and figure out what to do next. If you're interested in a more complete set of features, there's some documentation available on the VS Code Go documentation. I'm going to spend the last 5-ish minutes going through the behind the scenes of the integration of the debugger, which is Delve, with the editor. As I mentioned before, Delve is the program that will allow you to do all of these debugging features. But we're using it from VS Code. So we have a way that it's set up to allow us to communicate with Delve and get those features in our editor. So for the setup, we have VS Code in our Go extension, which provides the Go language features as well as the Go debugging features. When we want to start a debug session, VS Code will tell the Go extension, and the Go extension will launch Delve. So it will do that setup. Once it's launched Delve, Delve can communicate directly with VS Code using the debug adapter protocol, which I'll talk more about on the next slide. But this debug adapter protocol is how VS Code will tell Delve what program to launch and all that information, so that Delve can either attach or launch to a Go program, and then these will communicate with each other to give us the debugging experience that we saw here. So what is DAP? The debug adapter protocol standardizes an abstract protocol for how a development tool communicates with concrete debuggers. And what this means more generally is that the VS Code implements a client of the debug adapter protocol, so it speaks the same language to the Go debugger, the Python debugger, and the Java debugger, and all of these debuggers called a debug adapter because they implement the server side of the debug adapter protocol. What this looks like is a tool like VS Code will send requests to the debug adapter, like launching, or what variables are in scope, or what threads are available. And the debug adapter will in turn update the tool with what's happening with the process by sending events, like telling the tool that the program has stopped because it hit a breakpoint. And what does this mean for you as a Go user? Is that because the Delve is a debug adapter, it implements the server side of the debug adapter protocol. It can be easily talk to any editor that implements a DAP client. With minimal additional configuration, the debugging experience can be used from any editor. And to kind of hammer this point home a little bit, my coworker Rob Finley set up this treasure hunt on using Vim and Vim Spectre, and was able to use it to investigate the clues. So even though this treasure hunt was designed for VS Code, it was easily translated to Vim Spectre, which implements a debug adapter client. So lastly, I just want to finish off with thanking the Delve maintainers for all of their hard work on creating such a great tool, as well as to the Go team for all of their feedback and support on this talk. And I'll just throw up this slide with the links to the software I had